Okay friends, continue with a new video. So we have drawn the structure of the quinolines. Quinolines. This is the quinoline structure. This is the quinoline structures. In this quinoline structure, we are going to add the electrophilic substitution reaction at the position 8. This is the position 8. Okay, where is the electrophilic substitution takes place. So after electrophilic substitution, we will get the product looks like no big changes. Only change is that here is the hydrogen atoms at each carbon atom. This hydrogen atom is replaced by the electrophilic atoms. Electrophile. It is replaced by the electrophilic atom or electrophile like NO2, SO3H. Okay. It in the place of E we can take as NO2, SO3H. These types of electrophile we can take. So you are I know I think you can understand the general criteria what will be the reactions. Okay, now there is a substitution reaction at the position 8 takes place by the series of the steps. That step is also important for us. So how to draw these steps? This steps is simple one. How it is simple? We have to draw the total resonating structures, whatever it may be. In the structure there are 1, 2, 3, 4, 5, 6, 7, 8 structures are there. So we have to draw total resonating structures of these quinolines at position 8. So start drawing this first structure. This is the first structure. This is the first structures. In the first structures we are breaking this bond. We are breaking this bond, double bond, and after breaking this bond we will get the one part is negative part, one part is the positive part, one part is the positive part, one part is negative part, whatever be it may be. So it maybe looks like is the positive, is the negative. It may be possible like this, so you can take negative and positive also. But decide on which side we are going to be add the electrophiles. So by depending on that types we decide where we have to give the charges. So this is the best. This is the best because negative charge is on the position 8. So here is the electrophile will be going to be add. Means next step is that here is the electrophile added on the position 8. Means position 8 looks like simple way we can draw after additions. Position 8 looks like electrophile. It is looks like electrophile final product, but it passes through the different transition states. That transition state also we have to be mentioned in this step, because in the notes they are explained. So for removing the confusion, I can draw so that you can understand. In this, the first step, we draw the first step. In the first step, structure looks like this. Here is the electrophile, here is the hydrogen, here is the plus charge, double bond. Now the resonance structures are obtained, so this bond is shift here. This is the first structures mentioned in our notes. Here is the mention our notes first structure. If you problems on the notes, you can draw from this screen also. So this is the first step of this reaction. This bond shifted means that now in the next step positive charge will be formed here. In the next step positive charge will be formed here. So we can form the positive charge in this step. Positive charge form here is double bond, hydrogen, here is the electrophile. This is the step second. This is called as step second. Here is the step second. This is called as a step second, here double bond. Now double bond shifted at this position, means plus charge will become here in the next step. So in the step third, we can draw it. In the every step there is a general structure, that is general structure. Plus charge come here, double bond here, double bond here, hydrogen, electrophile. This is the step third mentioned here. Now plus charge will be shift here, means plus charge will be get here. In the next structure we will get the positive charge on these carbon atoms, double bond, hydrogen, electrophile. Now structure shift here, you will get the positive charge here. In the next positive charge here with a double bond, hydrogen, electrophile. This is the step, next step. Now in the next step again this double bond shifted to the next double bond, positive charge. Now it is shifted to the this carbon atom. From this double bond shift here, means plus charge come here. This is next step. Either bond shift here, plus charge come here. This is the next step. So in the final step, that this in this step, this is the most important step, where actually removal of hydrogen takes place. This is the final step. Here shift bond, this hydrogen bond shifted, this hydrogen removed in the form of H plus ions. As this shifted, there is a formation of bond, means we will get the final structure. This is our final structure. So in this way we can doing the various resonating structures. So we are discussing this. Now structure first, second, sixth and seventh are the more stable structure. Third, fourth, fifth are the less stable structure. So electrophilic attack at the 6th and 7th position give only two stable intermediate carbocation resonating structures. So these are all about the structure. First, second, third, fifth, sixth and seventh are more stable. So electrophilic attack at position 8 is again given the total structures how to draw, and here are the more stable state. So this is all about the resonating structure. You do practice about the drawing the resonating structure. We will meet in the next lecture. Thank you very much.